Okay, we're gonna do some GeoGebra. So first of all, these 3 videos here, translation, tutorial, reflection, tutorial, rotation, tutorial. Those will show you how to do those 3 transformations in GeoGebra. Don't forget that they're there. You might want to use them later. They're also in the help button in Canvas. All right, we have 2 practices here. I want you to click on the GeoGebra link for the reflection practice. Make sure you're clicking on the one after the purple writing. Excuse me. Because then you'll get this page. Now the first thing is you have all these directions on the left side. Unless you're going to use that, I don't ever use it. I just minimize it. If you click on this this line, you kind of grab it. You can get rid of that or just hide it. All right, so now we're going to reflect the given image over the line y equals negative 3x minus 1. And then we're going to do 1, 2, and 3. First thing we need to do is make a line. You should know that we can make this line because we know the y-intercept and the slope. You're going to click your line button, which is the 3rd button at the top of GeoGebra. And you're going to click line. And then we need to make this line. So our y-intercept is negative 1. Touch the screen at negative 1. And then we're going to do rise over run. The slope is negative 3 over 1. Every whole number has a 1 on the bottom. I'm going to go down 3, 1, 2, 3, and over 1, and put my second point there. That line now is y equals negative 3x minus 1. That's the line I want to reflect over. Now I need to click the polygon tool and choose the first option. And I'm going to click, it says select all vertices, then the first vertex again. Those are the corners. I'm going to click A, B, C, back to A. And then it is selected. And now I choose what I want this to do. This is my transformation tool. I want to reflect about a line because those are what the instructions tell us to do, to reflect the image over the line. I click in the center of the triangle and then right on the line, anywhere on the line, and it reflects it across, and that's the new image. All right, if you can do that much, that's enough for like a 2, I would say, nearly proficient. If you want to be proficient, you need to go another step or 2. So show parallel, I'm reading now number 1. Show parallel lines from pre-image to image. If you have your notes in front of you, we did this in our notes too. We are going to click the line tool. I'm going to do the line segment. That means the line will have an end. It won't go on forever, which is a little less busy. So I'm going to click A and then A prime. That's A with a little mark next to it. That means that is where it has gone to. The pre-image is the A with no hash mark. So pre-image to image on the B's, and pre-image to image point C's. Now your screen should look like that. Number 2, show that the slopes of those lines are perpendicular to the line of reflection. I'm going to do that one last. I'm going to skip to 3. Use circles to show the points from the pre-image and image are equidistant from the line of reflection. Remember that the line, if you look at the line of reflection, that's the line we created, and you look at, say, B and B prime, those 2 lines are equally distant from the center reflection point. We're going to show that by drawing circles. You're going to click your circle tool, and you want circle with center through point. I'm going to click right in the very middle of all of this where the line of reflection intersects the line connecting the 2 B's. So right there. And something happened. Oh, wait. Yeah. Oh, okay, got it. So in the center and then out to B. And then it creates a circle, and the radii, that is the distance from the center of the circle out to the side, so from the center to point B, for example, that is a radius, is the same as the other radius, the center point to B prime. We can do that again. Let's do it for C. Click right where the line connecting the 2 C's intersects with the line of reflection. and then click on C, and we've got that circle. And then do the same thing with the A's. So click on where the line connecting the A's intersects with the line of reflection. Right there, out to A. Now we have 3 circles, and we have used circles to show the points from the pre-image to the image are equidistant from the line of reflection. So those circles, because they're radii, that is radius plural, more than one radius, are radii of the same circle. That proves that they are the same size, which proves you did the reflection correctly. I'm going to skip back to number 2 here. Show that the slopes of those lines are perpendicular to the line of reflection. The way I'm going to show that is by showing that the perpendicular lines are actually perpendicular and are actually 90 degrees. So I'm going to measure the angle. If you look on my screen at where I have point G, capital G in the middle of the big circle, that angle where G is the point, where that letter G is, that's the one I want to measure. That should be 90 degrees, but I am going to prove it. I click the angle tool, pick the angle, and then in order to measure the 90-degree angle and not accidentally measure the exterior angle, the one that's on the other side, I'm going to start with C and then click around the 3 points of the angle. So I'm going to click on C, then capital letter G, then I can just click on D, and then it will measure that angle. If you zoom in, you can see that it is a square there, which is our symbol for 90 degrees, and it also says 90 degrees. See? Just like that. So I have proven that those lines are perpendicular because perpendicular lines are 90 degrees. You can prove all 3 if you want. I'm going to stop there. That is enough for a 4. You are going to screenshot this and put it in number, I believe it is 6.